Suppose now I would like to have more accurate result. I know now it's a losing game. This is one run of 1000 iterations, and the confidence interval is all on the negative side of right of zero. So I know I will be losing on average somewhere between $1.70 and dollar and 56 cents, between 56 cents and $1.70, right? With 99% confidence, I know the mean loss is somewhere in this range, and right, and then I can see that the size of the confidence interval, which I can calculate as the difference of upper and lower limit, is about $1.14. Now, can I reduce the size of this confidence interval to know better what actual mean payoff from this game is? Well, yes, I can if I increase the number of iterations. So, for example, I'll increase to 20,000 iterations and I run the simulation again, and let's see what will happen to the confidence interval. Now you see the drawback of this approach. The disadvantage is that the simulation now takes much longer to complete, right? It will take something like 26 seconds, 27 seconds on my computer to finish. Of course, the advantage is that now we get a much more accurate distribution. Actually, this distribution is being updated as the simulation progresses, and more iterations are added. And this distribution is probably more accurately reflecting the true probability distribution of all those possible winnings. So we can, for example, see that there is about 25% chance that we will win $5 in a game, and then the probabilities are decreasing. And notice, by the way, we now get a mean payoff of about negative $1 loss, and you see the confidence interval is much more narrow. If we wanted to narrow it even more, of course we can do it, but right, increasing the number of iterations will mean we have to wait even longer. So this is the trade-off, right? If you want more accurate results, run things for more iterations, but don't do this from the start, because you might discover that there is an error in your simulation and you would have wasted a lot of time. Simulate for smaller number of iterations, see if your simulation works well, if it gives you good results, and if it is inconclusive in terms of the question that you're interested about, then increase iterations, number of iterations if necessary.